Welcome to SWAYAM online lecture series on the topic database management system. My name is Muhammad Ubedullah Bukhari, working as a professor in the Department of Computer Science at Aligarh Muslim City, Aligarh. I am pleased to have you join me today. In this lecture, we will discuss few interesting topics including normalization for relational. So let us begin the journey of today's lecture. So let's begin the agenda of today's lecture, which is to discuss the following topics you can see on the screen. Normalization for relational database and normalization form along with example. So here we'll discuss about the normalization. What is normalization? Why I've already explained in the previous lecture what is the motivation behind normalization, and then difference normal form, example of different normal form, and the importance of normal form. So we will begin very first topic of today's lecture of normalization for relational database. Normalization is basically a process of minimizing redundancy from relation or set of relations. Redundancy in a relation may cause insertion, deletion, and updation anomalies. It means at the time of insertion, updation, and deletion anomaly will not certify, or anyone can not certify, then we can say this is not normalized. So it helps to minimize the redundancy in relations. Normal forms are used to eliminate or reduce redundancy in database. Normalization is a crucial process in database management system aimed at optimizing the structure of relational database to enhance the data integrity and minimize the redundancy. It involves organizing tables and their attributes in a systematic manner to ensure efficient data storage and retrieval. The process follows a series of normal forms, each addressing specific issues related to data redundancy and data dependency. In database management system, normal forms are a series of guidelines to help to ensure that the design of a database is efficient, organized, and free from all anomalies. The three anomalies are very important to check the relation is normalized or not. The three anomalies are insertion anomaly, next is deletion anomaly, and the third is updation anomaly. There are several levels of normalization, each with its own set of guidelines known as normal forms. Now let's discuss the types of normalizations. There are several types of normalization, each addressing specific issues related to data redundancy and data dependency. The most common types of normalizations are: first normal form, we can say 1NF, second normal form 2NF, third normal form 3NF, and Boyce-Codd normal form BCNF, fourth normal form 4NF, and the fifth normal form we can say 5NF. These are the common types of normalizations. So let's discuss each normal form in details. First normal form is the initial stage of database normalization in database management system aimed at organizing tabular data to eliminate the redundancy and ensuring data integrity. In first NF, each table in the database must meet the following criteria. It must be atomic, and the attributes must not be further divided. So the atomic means each attributes or column within the table must contain atomic value, meaning that each value in the column should be indivisible. This ensures that there are no multi-valued and composite keys. Next is unique column names. Every column in the table must be a unique name. This prevents ambiguity and confusion when referencing attributes in a query. It means a primary key. By that we are able to retrieve information uniquely. Ordered row. The row in the table must be ordered, meaning that there is a specific sequence or order in which rows are stored. This allows for consistent or predictable retrieval of data. By adhering to these criteria, it means unique column name, order row, atomic value, first normal form ensure that data is organized in a structured and consistent manner, facilitating efficient storage, retrieval, and manipulation of information. Achieving first normal form is typically the first step in the normalization process, laying the foundation for higher normal form such as second normal form and the third normal form. For example, the relation we take an example of a relation imply. Here, take the imply table. The attributes name is imply ID, second is imply name, third is imply phone, and imply state. You have to check the relation imply is first NF because of multi-valued relations phone number. Here, the phone number for imply ID 14 or the name John has a two phone number 7272826385. There are two phone number. Then we have to decompose imply table into first normal form, and this will become like that. Imply ID, imply name, and phone. Here the imply phone, that attribute must have an atomic value, so we have divided into two rows. So in this way, we are able to convert this relation into first normal form. In the second normal form is the second stage of database normalization in the database management system. Following first form, its primary goal is to further eliminate redundancy and dependency issues in the relational database. In second normal form, a table must meet the following criteria. It means we have to remove the redundancy. If you will remove the redundancy, integrity should be maintained. In the second normal form, it must be its first normal form. Before a table can be achieved 2NF, it must first satisfy the requirement of first normal form, including having atomic value and unique column name. Remove partial dependencies. In that case, you have to remove the partial dependencies. In second normal form, every non-prime attributes, attributes that are not part of primary key, must be fully functionally dependent on the entire primary key. This means that each non-prime attributes must depend on the entire primary key, not just a part of it. If any non-prime attributes is dependent on only a portion of the primary key, it indicates a partial dependency and violates second normal form. To address the partial dependencies and achieve second normal form, the table may need to be decomposed into multiple tables. Here what we'll do, if we have to find this is not normal form, what if suppose a relation R the R must be decomposed into R1 and R2. So how you have to check before decomposition, you have to check. In other words, we can say that if we want to see the relation is normalized or not, you have to check all the three anomalies. Insertion anomalies. At the time of insertion, you are able to insert information easily without any dependencies. Delete information if the employee has fired or expired, retired, then what will do? How you, if you have to delete the information, if you in future you want what is the address of that employee, you are not able to retrieve information, so it will not fulfill that, not certify that. If you want to update the information, that suppose the address of the employee has been changed, at that time you are dependent, you have to see how many times the address are. So it also fall. It also, anyone will not certify any anomalies within 3 insertion, deletion and updation anomalies. Then we can say this relation is not normalized. So we have to decompose the relation. So then you have to decompose into multiple tables, which each table representing a separate entity or relationship. This decomposition ensures that each table contains only attributes that are fully functionally dependent on the primary key, thereby reducing the redundancy and improving the data integrity. Overall, achieving the second normal form helps ensure that the data is organized efficiently and accurately, laying the groundwork for a higher level of normalization and enhancing the overall quality and performance of the database. So we have to decompose relation. So I am taking one example. See, here I have taken the one example. Assume a school can store the data of teachers and the subject they teach. In each school, a teacher can teach one or more subject. Many teacher can teach one. Here in the table, you can see the teacher ID 25 can teach two subject, chemistry and biology. The age is 30 here. In the given table, non-prime attributes teacher age. There is a teacher age is dependent on the teacher ID, which is the proper subset of the candidate key. That is why it violates the rule of second normal form. To convert this table into 2NF, we have to decompose the relation in such a way that decomposition must be lossless. It means after decomposition of a teacher detail table and teacher detail table, suppose R1 and R2, when you will join, you are able to retrieve all the columns. You are not able to that. So here the teacher ID is 25, 26, 47, 83. Teacher age is 30, 30, 35. Here is if a teacher teaches many papers, no problem. But here teacher, if you want to find the age of the teachers, only you have to teacher ID, only you have to here. Here in the previous example, the teacher ID 25, there are 2 rows in the tables. Redundant is there in the teacher's age. So in this way, we are able to decompose the relation and then check here after decomposition both table. These are the in second. We can say into a table. After decomposition, we can say that this is in first normal form. Third normal form is the stage of database normalization in database management system. Following first normal form, second normal form, it aims to further reduce the redundancy and dependency every time you have to reduce the redundancy and dependency in a relational databases. In the first NF, a table must meet the following criteria. It must be in 2NF. Before a table can achieve 3NF, it must first satisfy the requirement of second normal form, including being a first and having removed partial dependencies. It means in third normal form you have to check it must be in first normal form, then it also satisfy in second normal form, then we have to check whether it is third normal form or not. Then what will do? You have to remove the transitive dependencies here. In 3NF, every non-prime attributes, I mean to say that attributes that are not part of the primary key must be non-transitively dependent on the primary key. This means that non-prime attributes should not depend on other non-prime attributes within the same tables. To achieve third normal form, table may need further decomposition to remove transitive dependencies. This process involves splitting a table into multiple tables with each table representing a distinct entity or relationship. By ensuring that each attributes depend only on the primary key and not on other non-key attributes, 3NF helps eliminate the redundancy and improve the data integrity. It means, and also we have to check all the three anomalies maybe. In other words, you can say if it will certify, if it did not certify, then you have to decompose the relation in such a way that it must be lossless. Overall, achieving third normal form enhances the overall quality and performance of database by organizing data more efficiently and accurately. It establishes a more robust data model that minimizes redundancy and ensures consistency, laying the groundwork for more advanced normalization techniques and optimizing database design. So we have to go the further. For you can see on the screen a very good example. I will explain by this example. Here I have taken one example of employee detail. The attributes are employee ID, employee name, employee zip, employee state, and employee city. So here the super key in the table or above are employee ID, and employee name. Employee ID, employee name, and employee zip, and so on. Here the candidate key is the employee ID. The non-primary key attributes in the given table, all attributes except employee ID are non-prime key and all are non-primary key attributes. By this on the screen, if you go through it, you are able to understand what attributes are non-primary key. Here, employee state and employee city depends on employee zip, and employee zip depends on employee ID. The non-prime key attributes employee state and employee city transitively depends on the super key of, we can say, the employee ID. It violates the rule of third normal form. It means by transitive property we are able to find that. That is why we need to remove the employee city and employee state to a new employee zip table with an employee zip as a primary key. So what we have to do? We have to decompose this one. So employee ID, what will do? You have to decompose the relation in such a way that must be lossless. Here I did. You can see on the screen employee ID, employee name, and employee zip. And the next is imply zip, imply state and imply zip. So if you know the imply zip, by that you are able to find the imply. By joining, you are able to find that the imply ID. In the previously, it will in the all are in the one tables. So here the transitively we are able to find. That's why we have to deposit. Come to the fourth normal form. Before fourth, there is a Boyce-Codd normal form. Boyce-Codd normal form is an advanced stage of normalization in database management system that built upon the principle of third normal form. It aims to eliminate the certain types of anomalies by further reducing redundancy and dependency in relational database. In BCNF, a table must meet the following criteria. Also, it must be in third normal form. Before a table can achieve BCNF, it must first satisfy the requirement of third normal form, including being in first normal form and second normal form and having removed transitive dependency. Functional dependencies on the candidate key. In BCNF, every non-trivial functional dependencies where the dependent attributes is not a subset of the primary key must be dependency on the candidate key. This means that every determinants, we can say the attributes determining another attribute's value, must be a candidate key. BCNF aim to address certain anomalies that can occur in third normal form, particularly those related to non-trivial functional dependencies, by ensuring that each dependencies in by ensuring that every dependency is based on a candidate key. BSNF eliminates the possibility of certain update anomalies, insertion anomalies, and deletion anomalies. In the previous, I have told you have to check all three anomalies must be satisfied. Achieving the BCNF may require the further decomposition of a table to remove dependencies that violates the Boyce-Codd normal form criteria. This decomposition involves splitting the table into multiple tables, each representing a distinct entity or relationships. It may be relation one-to-one, one-to-many, many-to-one, whatever. And ensure that each table adheres to the BCNF requirements. Overall, achieving a Boyce-Codd normal form enhances data integrity and consistency in the database by minimizing redundancy and dependencies. It provides a more robust data model that reduces the risk of anomalies and facilitate efficient data storage, retrieval, and manipulation. It will become faster. You can store efficiently, you can retrieve information very fast, and you can manipulate. So, the aim to eliminate certain type of anomalies by further reducing redundancies and dependency in the relational database. We take one example. Let's assume there is a company where employees work in more than one department. So here you can see on the screen the table employee ID 264 in India and employee ID 64 in India. His expert, employee department designing and testing, department type D394 and D394, and employee department 283 and this one. So here the same employee ID 264 is working in the two different departments as a designing and that. In the def table, the functional dependencies are employee ID determines employee country. If you know the employee ID, you are able to find the employee country. Employee department, if you know the employee department, you are able to determine the department types, and employee department number also you can types and department number you are able to find employee department. Okay. Candidate key is employee ID, comma employee department. ID is employee ID and employee department. This table is not BCNF because neither not imply because why it is the table is not BCNF because neither employee department, here the employee department nor employee ID alone are key. Here the combined candidate key, so it must be alone. So what we'll do? For that we have to convert a given table into BCNF. We have to decompose into, depending on the requirement, we have to decompose into 3. The first table contains employee ID and employee country. It means if you know the employee ID, you are able to find the country. If you know the employee department, you are able to department types also. If you know the employee ID, you are able to know the employee department also. So by that you are able to redundancy you can remove. So here we make a 3 and then we check this. In this case, BCNF will satisfy. Here for the first table employee ID candidate key, for the second table employee department, and in the third table employee ID or employee department. Now this is in BCNF because left side part of both the functional dependencies is a key. So come to the fourth normal form. In the fourth normal form also is a level of normalization in database management system that addresses multi-value dependencies within a relational database. It builds upon the principles of third normal form and aim to further reduce redundancy and improve the data integrity. In fourth normal form, a table must meet the following criteria. It means it must be first be in 3NF. Before a table can achieve 4NF, it must first satisfy the requirement of third normal form, including being a first and second and having removed the transitive dependencies. Eliminates multi-value dependencies. In 4NF, every non-trivial multi-value dependency must be dependency on a candidate key. This means that if a table has multiple candidate key, it should not have any non-trivial multi-value dependencies between attributes. Multi-value dependencies occurs when the presence of one or more rows in a table implies the existence of other rows with multiple values. Fourth normal form aims to eliminate such dependencies to avoid certain anomalies that can arise during the data manipulations. Achieving fourth normal form may acquire further decomposition of a table to remove multi-value dependencies. This decomposition involves splitting the table into multiple tables, each representing a distinct entity or relationship, and ensuring that each table adheres the 4NF requirements. Overall, we can say that we can achieve fourth normal form. Overall, we can say that fourth normal form enhances the data integrity and consistency in the database by minimizing redundancy and dependencies related to multi-valued attributes. It provides a more robust data model that reduces the risk of anomalies and facilitate efficient data storage, retrieval and manipulation. So we'll take one example. The student, for that the one attributes is a student ID, course and the hobby. One student can take a more courses and have a more, we can say, and have a more hobbies. Here in the given student table in 3NF, but the course and hobbies are two independent entities. Course and hobbies are two independent entities. There is no relationship between course and hobbies. In the student relation, a student with student ID, you can say in the screen, you can say 21, contains two courses, course computer science and math, and the two hobbies, dancing and singing. So there is a multi-value dependency on a student ID, which leads to unnecessary repetition of the data. So what you will do? You have to decompose the relation into table 1 and table 2. In table 1, a student course, a student ID and the course, a student hobby, a student ID and hobby. Here, no multi-valued value are in attributes. It means if student ID contains, okay, one course, okay, no problem. And also a student contains in another table, contains dancing, singing, whatever. So in this way, this table become a fourth normal form. So the last, or we can say fifth normal form, we'll discuss here. Fifth normal form, also known as project joint normal form, BCNF, is an advanced level of normalization in database management system that addresses joint dependencies with relational database. Here the joint dependencies. It extends the principle of fourth normal form and aims to further reduce redundancy and improve data integrity. In 5NF, a table must meet the following criteria. The main aim of normalization is to reduce the redundancy and improve the data integrity. So there are some criteria in the 5th NF have to. Fifth NF, it must be in 4NF. It must first satisfy the requirement of 4th NF, including being a first normal form, second normal form, third normal form, and having removed multi-valued dependencies. Joint dependencies occurs when the value of a certain attributes in one table are dependent on the value of attributes in the another table. In fifth normal form, aims to eliminate such dependencies by decomposing table into a smaller, more granular tables, each representing a distinct entity relationship. This decomposition ensures that each table contains only one attributes, are strictly related to its primary key and does not rely on other table for information. Overall, achieving fifth normal form enhances data integrity and consistency in the database by minimizing redundancy and dependency related to joint operations. It provides a more robust data model that reduces the risk of anomalies and facilitate efficient data storage, retrieval and manipulations. These are about the fifth normal form. So we take one example. I hope by that example it will be very clear to you. So I am taking one simple example. The table contains three attributes: subject, lecture and semester. Okay. Subject computer, Anishka and the semester 1. Subject computer, John, semester 1. Math, John, semester 1. Math, Akash, semester 2. Chemistry, Parveen, semester 1. You can see in the above table, John takes both John takes both computer and math class in semester 1. You can see on the screen, but does not take math class for semester 2. In this case, combination of all these fields required to identify a valid data. Suppose we add a new semester, a semester 3, but we do not know about the subject and who will taking that subject. So we will leave a lecture and subject as null. It means in the third semester we want to add, okay. But here the database is, you can say, relational database. All the attributes, the value of attribute must be not null. If you want to add a semester 3, at that time you cannot add the value of semester till you have to give the value of a lecture and subject also. Otherwise it will not. So, but all three columns together acts as a primary key, so we cannot leave other two column blanks or are like a primary key. So you have to enter the value. You cannot leave attributes blank. So here it creates a problem at the time of insertion. So what you'll do, you have to decompose the relation into three relations, P1, P2, P3. So in example, you can see in P1, semester 1 and subject, semester 1, computer, math, chemistry and math. In relation 2, you can say computer, math, chemistry and then lecturer. And the P3 must you have to semester and the lecturer. So in this way, we are able to, the additive tool will convert into 5NF. The first is reduce data redundancy. Normalization helps to eliminate the duplicate data in the tables, reducing the amount of storage space needed and improving the data efficiently. So by normalization, we are able to, in a consistent and organized manner, reducing the risk of data inconsistencies and error. Simplified database design. It provides a simple and easier to design and maintain database. Next is improved query performance. Normalized tables are typically easier to search and retrieve data from, resulting a faster query performance. By normalization, query performance will be improved, easier to database maintenance, and the last is data integrity. Data integrity minimizes the risk of inconsistencies and update anomalies such as insertion, deletion, and modification anomalies, which can occur when redundant data is present. The next is disadvantage of normal form. Increased complexity, query performance overheads, and storage overheads, potential for data inconsistency, complexity of updates and inserts. Maintaining the data integrity in normalized database can be more challenging, particularly when performing updates or inserts that involves multiple tables. Storage overheads. Normalization can result in increased storage overheads, especially when tables are decomposed into smaller units. So these are the disadvantages for that. Importance of normal form. Normal form are fundamental concept in relational database design, and their importance lies in their ability to enhance data organization, integrity, and efficiency. Normalization process involves applying rules to eliminate redundancy and dependency in the database table, offers several key benefits. Main to eliminate the redundancy and dependency in the tables. One of the primary advantages is the elimination of data redundancy. By decomposition of relation, complex table into a smaller, more manageable ones and organizes data efficiently. So normalization reduces the risk of duplicate informations. These are the advantages for that. This will not only save the storage space but also ensure that the updates or changes to data occurs in one place, promoting consistency and reducing the chance of conflicting informations. So these are about the database.